So in this next part of the geometry that we're talking about, we want to talk about things that are congruent. And we'll be seeing this word in the next section as well. When you see the word congruent, you need to be thinking about this. These are things that have the same size, they have the same shape, they have the same measure. Okay. They're copies. They are exact copies, replicas, duplicates. Okay? So when we talk about congruent angles, we're talking about angles that have the same size, same shape, they have the same measure. Okay? So if I were to do this guy right here, let's call this angle A. Let's call this angle B. If I say that angle A is congruent, now here's how we show congruency. It's like an equal sign. It's kind of Spanish. Okay, he's got the little ñ on top of him, right? Isn't that the right? Is that what you call that? Yeah. So he's Spanish. So we would say this, angle A is congruent to. So this means is congruent to. And so here's what that means for me. If I tell you that this guy right here measures 35 degrees, then what does angle B measure? 35 degrees, because it's the same. So notice there's a difference here. Angle A is congruent to angle B. And what that means is that the measure of angle A equals the measure of angle B. Okay? When you start talking about the measurement of something, you drop that congruency and you can say those measurements are equal. You're equaling the measurements. So the angle is the construction. The measure of the angle is a little piece of that. It's talking about the characteristic, the quantity of 35 degrees. Okay. Let me ask you this question. Are complementary angles congruent? Now, there's a kid that I help with in geometry, and the questions that he really struggles with the most are questions where you have to respond always, sometimes, or never. Okay? Is this statement true always? The complementary angles are congruent? Is it sometimes true or is it never true? Are complementary angles congruent? Sometimes? It's just a guess. Okay. Well, look at the examples we've done before. Have we had complementary angles being congruent, being the same measure? Have we had that yet? No. But is it possible?
Maybe.
See, so what you're saying is that we should be able to add two angles to get 90, but they have to be the same, right? So that means that if I took, say, x plus x, we want that to equal 90 degrees, right? Is that possible? Yes, it is, because this is an equation now. This is what you're trying to find out. When are two angles equal to 90, and when are they the exact same? So combining x and x gives you what?
2x.
So 2x equals 90, and the only way this can happen is when x is equal to what? When x equals 45. When it's equal to 45 degrees. So here's what we talked about. We've talked about having angles being complementary. That means they add up to give you something that is 90 degrees, like this. So can these guys be the same? Yes, and the only way they can be the same is when these guys are congruent. So when these guys are both 45 degrees. Are you with me on this? And the way we may see this in a diagram that things are congruent is that we'll see measures like this. We'll see little arcs in there. So as long as it's the same arc, then we know that these guys are congruent. If you have multiple sets of congruent angles, you may see different notations like this. You may put a little dash through it like that to denote that the one that has one mark through it, these guys are all congruent, as opposed to the ones that may have two marks through that. And let me show you that here, because this is one of the easiest ways to see that the angles are congruent. Here I just have two intersecting lines. Okay. Are these lines perpendicular? If you say they're perpendicular, you say that they're intersecting to form right angles, which means that you could take something that has a square corner, like my ruler, and you can slide it into the corner. It's going to fit in perfectly. Let's see, that doesn't slide in there perfectly, does it? Yeah, I guess it's because, I've got it at a weird angle, right? But I think it's pretty clear to see that this is not going to work out. Okay, not a right angle. Are these guys parallel? No, why are they not parallel? Because they intersect, right? You can't have parallel lines intersecting. What kind of madness is that? Right? Am I right? I know I'm right. Okay? Okay. So here's what we have. Opposite angles here at an intersection, these are called vertical angles. So if I just label these guys here, 1, 2, 3, and 4. In this diagram, angle 1 and angle 3 are what we call vertical angles. Okay? They are exactly opposite of each other at this intersection, right? You guys may say they're what? Catty corner? Has anyone ever heard that expression, or is that just my wife making up things? You've heard of it? It must be a Texas thing, right?
Yeah.
She's from Texas, and so she don't talk like this. I don't think anybody from Texas talks like this. But so catty corner, opposite corners of each other, right? Do you have any other vertical angles? Angle 2 and angle 4 are also vertical angles. And here's the great thing about vertical angles. If you remember taking geometry, you probably use this so many times. This is the big kicker. Vertical angles are congruent. And if they're congruent, they have the same measure. And there's lots of stuff that you can get from that. Okay? So here's the fun that we can have here. If I say that the measure of angle 1, I want to say this guy is equal to 57 degrees. Could you find the measure of the other angles in this diagram? With reason why? Can you give me the measure of any of these other angles?
Number 3 can be same.
The measure of angle 3 should also equal 57 degrees, right? Why is that? What did I just say? Vertical angles are congruent, which means they have the same measure. Now you could show that in the diagram by doing this. These guys have the same measure. Could you find the measure of angle 2?
Yes.
How?
180 minus 57.
Where'd you get the 180 from?
Because it's straight.
This right here is a line, right? So it's also got a straight angle. So we know that if I add 1 and 2, I get 180. Right, Tim? So to find this is like finding the supplement. So the measure of angle 2 is just 180 minus 57. And what's 180 minus 57? What'd you get? We get 123 degrees, right? Now, how could you find the measure of angle 4? Why would it be the same? Because these angles are congruent, because they are what kind of angles? Vertical angles. True that. True that. Now, you can show these guys are congruent in this diagram by doing these arcs like this, but we might do it. We can't do it like this. That doesn't work out. We'd have to do like a line through it like this. So that means in this diagram, anything that has this particular arc to it with the single dash would be congruent to anything else that looks like that. The arc just by itself, these guys are going to be congruent. That means they're equal to each other. Okay, the measures are equal. You with me on that? You have a question?
Angle 1 and 3.
These guys, angle 1 and angle 3 are vertical angles. So, angle 1 is congruent to angle 3 because they're vertical angles. And that means to us that the measure of angle 1 is equal to the measure of angle 3. The measurements have to be equal. And then when we're working with 1 and 2, we saw here, if I can just close out everything else that's going around there. Sometimes that's what you have to do. Block out the stuff that you're not working with. And if I see this, I see that this would make 180 degrees. It's a straight angle. So I just need to find the supplement of 57 degrees, which is 123. And of course, once I have 123, you could then do this. These guys are also supplementary, but you don't have to do that. You could just see that these guys are vertical angles. So you've got that congruency that's going on there.